Deep beneath the quiet hum of Earth's radio telescopes, something is missing. For decades, we've listened to the stars, scanning the void for even a whisper of alien life. But what we've found is nothing. No signals, no structures. Number, signs, just an overwhelming, impossible silence. In a universe with trillions of worlds, why is no one talking? What if that silence isn't accidental, but a warning, or worse, a clue? Because if the cosmos is this quiet, then maybe we are not only the first to arrive, but the last to survive. Join us as we uncover the eerie possibilities behind the cosmic silence, and what it could mean for our future. Subscribe if you believe the universe still hides ancient truths waiting to be heard. In the dry valleys of Northern California, where dust swirls like whispers through the air, there stands a strange forest of steel, rows upon rows of satellite dishes, pointed skyward like outstretched ears. This is the Allen Telescope Array, and this is where the silence begins. Dr. Lena Morris arrives just after dawn, coffee in hand, hair still wet from the shower trailer parked beside her lab. She's been working here for 17 years, chasing something that may not exist. Every morning, she scans the night's data, bands of frequencies, columns of static, lines of nothing. Occasionally, there's a spike, interference, a passing satellite, a false hope. She knows better than to flinch. Lena is one of the few who still listens, truly listens. She once called it the loneliest job in science. Her colleagues, those who haven't left for private space tech firms or tenured university posts, joke that she's searching for a ghost in a stadium full of mannequins. And yet, she keeps listening, because if there's even one whisper out there, one deliberate pattern in the chaos, it changes everything. The telescope array feeds its data into a central neural net trained to flag anomalies. Millions of signals filtered, scored, and deleted. Every now and then, a ping, an irregular rhythm, a hint of modulation. Lena hovers over it, heart pounding, only for the algorithm to blink red. Terrestrial origin, likely. She leans back in her chair and exhales. We often imagine that the universe is teeming with life. Civilizations building colossal cities beneath red suns. Alien minds decoding light waves beyond our comprehension. But so far, all we've heard is silence. A silence so vast and so consistent, it has become a scientific riddle, a haunting one. It's called the Fermi paradox. In short, if the universe is as ancient and immense as we believe, and if intelligent life is a natural outcome of evolution, then where is everyone? Why haven't we found even a trace? We've mapped thousands of exoplanets. We've listened across hundreds of radio frequencies. We've sent signals, probes, even golden records with Mozart and Carl Sagan's heartbeat etched into them, and still, nothing. The cosmic silence isn't just unsettling, it's statistically improbable. Imagine standing in the middle of Times Square at midnight and shouting. You expect echoes, a response, a honk, a laugh, a window opening somewhere. But now imagine you've done this every night for a century and heard nothing in return. That's where we are now. Lena recalls a moment years ago. She was reviewing old SETI logs and came across the infamous WOW signal from 1977, a perfect 72-second burst from the Sagittarius constellation. No explanation, no repeat, just one inexplicable blip. She stared at the readout for hours. What if that was it? She asked aloud. A younger colleague replied, then we missed our only chance. And maybe we did. The Fermi paradox isn't just a question, it's a shadow, a growing doubt that maybe we've misunderstood everything. Maybe life doesn't arise as easily as we think, or worse, maybe it does, but it doesn't last. Because if we're listening across all these frequencies and still hearing nothing, no pulses, no beacons, no technological signatures, then the silence might not be empty. It might be telling us something, but what? In the Alan Array's operations log, there's a page that Lena keeps bookmarked. A simple graph of observed signals across 25 years. A flat line, not a spike, not a blip. Just a pure, cosmic quiet. She once joked, it's the most honest sound in the universe. And yet, night after night, she comes back. Headphones on, eyes scanning waveforms like a heartbeat monitor for the cosmos. Waiting, hoping, she tells herself. The signal could come any night. That someone, somewhere, might finally say hello. But what if the silence is permanent? What if there are no others? What if we're the signal, the lone voice broadcasting into a deaf and dying void? We humans have a complicated relationship with loneliness. We can't stand to be alone in a room for long, let alone a universe. Our myths, our gods, our sci-fi dreams, they're filled with others, better others, wiser ones. Beings who can guide us, challenge us, understand us. But what if we are all there is? It's a terrifying possibility, one that scientists like Lena don't say aloud often. But when the coffee goes cold and the static hasn't changed in years, it creeps in, quietly, relentlessly. Maybe the universe was never built for conversation. Maybe it was always meant to be a monologue. Or maybe, just maybe, we're still too early, still learning how to listen. And in the grand story of the cosmos, we're only on the first page, whispering into the dark, waiting for a voice to answer back. But what if the universe was designed for life? What if everything, from the formation of stars to the complexity of DNA, points toward a cosmos where life isn't rare, but inevitable? That's where we go next. Let's zoom out past the Allen Array, past our blue planet and its thin shell of atmosphere, past the swirling arms of the Milky Way, out into the vast, cold ocean of stars. There are more galaxies in the observable universe than there are grains of sand on all Earth's beaches. Over 2 trillion of them, each with hundreds of billions of stars, and orbiting those stars, planets likely septillions of them, worlds of fire and ice, gas and stone, moons larger than Earth, oceans without skies, super-Earths and rogue giants, drifting in the dark, and yet silenced. How? Dr. Aimd Hashem has spent his career trying to answer that question. An astrobiologist with the European Space Agency, Aimd doesn't just search for life, he asks what it takes to make life. His lab in Geneva looks like a futuristic terrarium, vats bubbling with ammonia, petri dishes that mimic Martian soil, and sealed chambers recreating the pressure of Europa's under-ice ocean. If life exists anywhere, he says, it should exist everywhere. The building blocks of life are not rare. Hydrogen, carbon, nitrogen, oxygen, they're among the most abundant elements in the universe. The same amino acids that formed in Earth's primordial soup have been found on comets, asteroids, even in the atmosphere of Titan. It seems the universe wants life, and yet, when we look, really look, we find emptiness. Let's start with the basics, the Goldilocks zone, or habitable zone, the region around a star where a planet could have liquid water, not too hot, not too cold, just right. NASA's Kepler mission identified over 4,000 confirmed exoplanets. At least 50 of them lie within their star's habitable zone, and that's just a fraction of the sky. Statistically, the Milky Way alone could host 40 billion Earth-like planets. So, where are the civilizations? Ames turns to a paradox of probability, the rare Earth hypothesis. Maybe the conditions that make Earth so perfect are astronomically rare. A magnetic field to protect us from solar radiation, a large moon to stabilize our tilt, plate tectonics recycling carbon, a gas giant like Jupiter to deflect incoming asteroids. Lose just one, and you lose life. But others argue the opposite, that life is robust, that it wants to happen in Earth's own history. Life arose almost as soon as it possibly could, within 500 million years of the planet's formation. It survived asteroid impacts, volcanic winters, global ice ages. Life, as the saying goes, finds a way. Just ask the extremophiles in Antarctica's Lake Vostok. Buried under 2 miles of ice, microbes flourish without sunlight. In the Mariana Trench, where pressure could crush a submarine, strange, bioluminescent creatures dance. Near hydrothermal vents, bacteria feed on sulfur, not sunlight. If life can thrive here, why not on Europa, or Enceladus, or Ganymede? We've even found bacteria in the stratosphere, living, dividing, enduring. Some scientists believe these microbes could survive interplanetary travel, hitching rides on rocks flung from planet to planet. It paints a picture that's almost hopeful. Maybe life is everywhere, just hiding beneath the ice, or buried beneath deserts, or existing in chemical signatures we don't yet understand. But still, we wait. We look for in exoplanet atmospheres, the faint fingerprint of methane, oxygen, chlorophyll. We scour the skies with spectroscopes, more powerful than ever before, and yet every reading comes back the same. Inconclusive. Ames recounts a moment that shook him. In 2020, astronomers thought they had found phosphine on Venus, a gas that, on Earth, is produced almost entirely by living organisms. For a brief moment, the world held its breath. Then came the retractions. The signal was noise, or a miscalculation, or maybe just hope coloring the data. It's hard to admit, but maybe we want life out there because the alternative is too heavy to bear. Ahmed once told a group of students, we look into the universe and see reflections of ourselves, not because the cosmos is like us, but because we are desperate not to be alone, and perhaps that desperation blinds us still. The numbers keep whispering, the Drake equation, a mathematical attempt to estimate the number of detectable civilizations, offers both promise and dread. Change one variable slightly, and the galaxy teems with life. Change another, and we are the only candle in an infinite dark. So we stand at a precipice, a universe built with the tools of life, but seemingly empty of its result. Is life inevitable? Or is it a cosmic accident? And if life is common, then the silence becomes more disturbing, not less, because now it isn't just about probability, it's about absence, and that absence leads us to the most haunting question of all. If the ingredients are here and the ovens are everywhere, why is no one baking? Perhaps they were once long ago. Which brings us to one man, one question, one paradox that still echoes through time. It was a warm summer afternoon in 1950 when physicist Enrico Fermi sat down for lunch at Los Alamos National Laboratory. Around the table, Emil Konopinski, Edward Teller, and Herbert York, three of the brightest minds in nuclear physics. The conversation, as it often did in those days, drifted toward flying saucers and recent UFO sightings. And then, between bites of lunch, Fermi asked a question so simple, it cracked open one of the greatest mysteries in science. Where is everybody? That moment, mundane and profound, would come to define the modern search for extraterrestrial life. Because behind that question lay a terrifying contradiction. Statistically, the galaxy should be filled with life. Civilizations, billions of years older than ours. Colonies spread across stars. Signals crisscrossing the void. And yet, nothing. Not a whisper. Not a trace. That tension between probability and silence became the Fermi paradox, and for 70 years it has haunted science. At first, the paradox was brushed aside as a philosophical riddle, but as technology improved and telescopes reached farther, it became impossible to ignore. By the 1970s, SETI, the search for extraterrestrial intelligence, was in full swing. With massive dishes tuned to the stars like stethoscopes pressed to the heavens, and still silence. That silence became deafening. Today, the Fermi paradox isn't just a question, it's a pressure point, a crack in our assumptions. Because the more we look, and the more we don't find, the more we're forced to consider disturbing possibilities. In the Fermi framework, there are only 3 broad categories of answers, and each one changes everything. Possibility 1. Intelligent life is rare. So rare, in fact, that Earth is an anomaly, a freak accident of chemistry and time. If that's true, we may be alone, not because others are hiding, but because there simply are no others. This view is chilling. Not because it's lonely, but because it makes us fragile. A single planet, a single species, a single mistake, and the light goes out forever. Possibility 2. Life is common, but intelligence is rare. Perhaps microbial life is abundant, swimming beneath the ice of Europa, thriving in sulfur lakes on exoplanets. But intelligence, that's the fluke, the exception. Maybe self-awareness is a dangerous evolutionary glitch, one that burns out long before it spreads. Or maybe intelligence always leads to destruction, nuclear war, resource collapse, artificial intelligence that escapes control. Perhaps every species reaches a technological tipping point and doesn't survive it. This idea gave rise to a theory we'll explore in detail soon, the Great Filter. But there's a third possibility, and it's the most unsettling possibility. 3. Intelligent civilizations are out there, maybe even in abundance, but they are silent. Deliberately, we'll dive deeper into that dark possibility in coming chapters. But here, with Fermi's question still fresh, we must pause to acknowledge its brilliance and its cruelty, because the paradox isn't about aliens, it's about us. It forces us to look in the mirror and ask, what are we missing? What assumptions blind us? What dangers lie ahead that others didn't survive? It's no longer just about whether alien life exists. It's about whether we are prepared to become one of those rare civilizations that not only emerges, but endures. Let's explore a thought experiment. Imagine a billion-year-old civilization, spread across thousands of star systems. Their technology is unimaginable. Energy harvested from stars, minds stored in machines, Consciousness unbound by biology, would they bother to contact us? Would we even recognize their communication? Dr. Jill Tarter, one of the founding figures of SETI, once said, "We could be surrounded by intelligent life and not recognize it, like ants trying to understand the internet." That's the blind spot Fermi exposed. Our assumptions. We assume aliens would use radio waves, that they'd want to talk, that they'd be like us in ways that matter. But what if they've transcended matter itself? What if their language is gravitational waves, or quantum entanglement, or dimensions we haven't yet imagined? The Fermi paradox holds a mirror up to our hubris. It asks us, are you really listening? Or are you just waiting to hear your own voice echoed back? In recent years, researchers have tried to reframe Fermi's riddle. Some suggest we need a new equation, one that accounts for technological maturity, not just biological emergence. Others say we're still in the early days of listening, and that a few decades of silence is meaningless on a cosmic scale. After all, the universe is 13.8 billion years old. We've had radio technology for just over 100. Maybe we haven't heard anything yet, because we're late to the party. Or maybe it hasn't started, and yet the silence continues. So we return to Fermi, sitting with his coffee, asking the one question that still breaks the sky open: where is everybody? And if someone is out there, why are they so quiet? That brings us to a radical theory, one that flips the entire paradigm on its head. What if they see us? What if they hear us? What if they're deliberately ignoring us? Imagine, for a moment, that Earth is not isolated, not ignored, but observed, not from above, but from afar. This is the unsettling core of the zoo hypothesis, a theory that suggests we are not alone, but part of a cosmic wilderness preserve, one where more advanced civilizations know about us and are choosing to remain silent, like zookeepers watching animals from behind the glass. They watch us, curious, detached, and forbidden to interfere. The idea first emerged in the 1970s, proposed by astrophysicist John Ball. He argued that the silence of the universe didn't stem from absence, but from policy, a galactic consensus not to reveal oneself to young, undeveloped species, like children in a room full of adults. We are being silently assessed, and perhaps protected. Dr. Elaine Mock, futurist and longtime advisor to the SETI Institute, has spent her life thinking about alien ethics. If a civilization is advanced enough to cross star systems, she says, they're likely advanced enough to consider moral consequences. She leans forward. Would you interfere with the culture of a newly discovered tribe? Or would you observe quietly to avoid contamination? The zoo hypothesis rests on this same anthropological restraint, that contact could harm us, accelerate us too quickly, or worse, destroy the innocence of our self-discovery. It's not hard to imagine. Human history is filled with examples of destructive contact, of indigenous cultures overwhelmed by sudden exposure to advanced technology. What if the universe learned from our mistakes, long before we even made them? But then, an unsettling question: who made the rules? If the universe operates by some cosmic prime directive, then somewhere, out there, are civilizations powerful enough and united enough to enforce it. A kind of galactic government, a federation of silence, one that monitors intelligent life as it emerges, but never makes contact until it's ready. But what defines ready? Is it the ability to reach the stars, to eliminate war, to preserve the environment, or to prove that we won't destroy ourselves? Elaine points to one possibility: the observation threshold. The idea that alien civilizations are watching for certain technological markers, long-range communication, artificial satellites, interplanetary travel. Once a species crosses enough of these, they graduate from being watched to being welcomed. It's a seductive idea that we are on the verge of graduation, that someone out there is waiting for us to grow up. But there's another, darker side. What if we're not being observed, but studied? Not a zoo, but a lab, and we're not guests, we're specimens. There are versions of the zoo hypothesis that lean toward cold detachment, civilizations that see us not as potential equals, but as curiosities, biological data points, cultural simulations, ants under the microscope of beings who long ago transcended the need for empathy. That version feels less like science fiction and more like existential horror. Elaine admits it's speculative, but urges caution. The real danger isn't whether they're watching, she says. It's whether they've decided we're irrelevant. This leads to what some call the non-intervention protocol, a theoretical rule set that prevents contact until a species demonstrates sustained survival without self-destruction. The logic is simple. Why waste resources or attention on civilizations that won't last? Viewed through this lens, Earth becomes a test, a proving ground. Will we pass? And then there's the unnerving possibility that we've already failed. What if someone tried to contact us millennia ago and we missed it? A monolith lost to erosion, a signal that arrived before radio, a genetic tweak buried deep in our DNA. What if we were already touched and simply weren't ready? Some ancient astronaut theorists point to mythology, monuments, or unexplained artifacts. But even without leaning into pseudoscience, there's a haunting idea that our lack of contact says more about us than it does about them. Maybe we've been watched all along, and maybe we're not worthy yet of a reply. There's a quiet comfort in thinking we're part of something larger, that we are not isolated but incubated, that the silence is not neglect, but patience, and yet the longer it stretches, the more it feels like abandonment. Elaine recalls a thought experiment she gives her graduate students. She asks, if we found a planet filled with early human-level intelligence, cave paintings, fire, maybe even religion, would we contact them or just watch? The class splits. Some say yes, others no, and then she asks, what if they started broadcasting radio? That's where the debate always gets louder, because if the zoo hypothesis is true and we are transmitting every day, every second, then someone is hearing us, choosing not to respond. And that, in itself, is a kind of answer. Perhaps they're waiting for us to ask the right question, or perhaps they've already decided they won't speak at all. But what if it's not about ethics? What if the universe is silent because something happens to civilizations before they can speak? What if the silence isn't chosen, but enforced by nature, time, or something worse? To explore that possibility, we must walk into the shadow of a far darker theory. In the deep corridors of existential science, there is a theory so unsettling, so cold in its implications, that even seasoned researchers hesitate to speak its name without a pause. It's called the Great Filter, and if it's real, it may already be behind us, or silently waiting just ahead. The Great Filter is not a single event or disaster. It's a concept, a wall, a barrier in the timeline of intelligent life that stops civilizations from advancing beyond a certain point. It's the reason, perhaps, that the universe is silent because everyone else didn't make it to understand the filter. Imagine the evolutionary steps that led to humanity, from the birth of stars, to the formation of planets, to single-celled life, to multicellular organisms, to tool use, language, agriculture, technology, and now, space flight. Each step represents a narrowing funnel, a statistical improbability. Now ask, which step is nearly impossible? Which one is the great filter? Dr. Richard Hanna, a complexity theorist at MIT, describes the filter as the moment in a civilization's development when its technological power outpaces its wisdom. If the filter is behind us, if the emergence of life itself, or intelligence, is the hardest step, then we may be one of the lucky few to have made it through. Alone, but victorious. But if the filter lies ahead, then we are in grave danger, because that would mean every civilization that reached our level of advancement, the ability to harness nuclear power, alter the environment, develop AI eventually collapsed, extinction by innovation, collapse by complexity. Richard points to Earth's own near misses, the Cuban Missile Crisis, where the world stood one breath away from nuclear annihilation, the unchecked acceleration of climate change, the rise of artificial intelligence with no ethical constraints. All of them, he says, could be the filter, or precursors to it. And this isn't just science fiction. In 2019, a study published in Scientific Reports modeled the collapse of advanced civilizations due to resource exhaustion. Most outcomes ended in extinction. The few survivors, reduced to agrarian simplicity, unable to rebuild. If intelligent, life tends to self-destruct, then the silence makes sense. Everyone who came before vanished before they could speak. Some theorists go even further. They suggest that the very act of broadcasting, of reaching out, might trigger the filter. That drawing attention in a dark universe invites destruction. That silence is not just survival, but safety. We'll explore that theory in full soon. But here, with the filter looming, the question becomes deeply personal. Have we already passed it? After all, we've survived billions of years of asteroid bombardment, mass extinctions, and ice ages. We've evolved intelligence, created global civilizations, even begun our journey into space. Could that mean the filter is already behind us? The rare, improbable step that most worlds never achieve, and we did. It's a hopeful idea, one that paints us as survivors in a universe littered with failure, but it's just as likely. We're mid-filter, teetering in the 21st century alone. We've invented technologies with the power to end civilization, from autonomous weapons to bioengineering. Our atmosphere is warming at an unprecedented rate. Antibiotic resistance grows, ecosystems collapse, and all the while, we argue over the trivial. Richard recalls a late-night conversation he had with Carl Sagan's former assistant. They discussed the Voyager golden record, humanity's message to the stars, music, greetings, art, mathematics, a snapshot of Earth's brilliance. But he wonders now, was it premature? What if, in trying to announce ourselves, we assumed we had already survived the test? There's a dark symmetry here, a universe filled with planets, many of which may have hosted life, civilizations that burned bright, broadcast once, and then fell silent, leaving behind ruins, artifacts, maybe even signals, long decayed, distorted by time, and us, standing at the edge of their footprints, wondering why they disappeared. The great filter forces a grim reflection. Not just where is everyone, but will we make it? It's a theory with no comfort. Either we are special or doomed. But there is one last possibility, one Richard hesitates to say aloud. What if the great filter isn't universal, but enforced? Not a natural barrier, but a pattern, a law, an intelligence that ensures no species crosses a certain threshold. We'll go there soon. For now, we must ask, what can we do to survive? Some say we must spread out, colonize Mars, build orbital habitats, diversify humanity across space. Others say survival depends not on technology, but on empathy, on learning how to manage power without destroying ourselves. One thing is clear, the silence above isn't just a scientific puzzle. It's a warning. Whether the filter is behind us or ahead, it casts a long shadow, and it makes us look at every near catastrophe, every nuclear standoff, every pandemic with new eyes. Because maybe the universe isn't empty, maybe it's a graveyard, and Earth is just now approaching its headstone. But what if the silence is not because we failed, but because we misunderstood the signal entirely? What if contact already happened, and we missed it? On August 15th, 1977, a faint, unassuming radio signal swept across the sky, brushing the detectors at Ohio State University's Big Ear telescope. For 72 seconds, the universe broke its silence a spike, crisp and clear, in the wilderness of static. Astronomer Jerry Emin circled the printout in red ink, writing a single, electrified word in the margin. Wow! It was the most tantalizing moment in the history of the search for extraterrestrial intelligence. The wow signal seemed so deliberate, so perfectly in line with what scientists hoped to find, that for days the astronomy world buzzed. News headlines speculated wildly. Was it a beacon from another world? A cosmic hello? Or just another false hope? But the signal never repeated. For decades, researchers aimed their dishes at the same patch of sky, searching for another whisper. Nothing, not once. The wow signal faded into scientific folklore, a ghost in the machine. But Jerry Emin's red ink scrawl echoes a question that lingers today. What if the signals have already come, and we simply missed them? SETI's search is a game of patience and uncertainty. We listen for narrowband radio signals, beacons that would rise above the cosmic noise. But the universe is not required to shout on our frequencies or use our technology. In fact, the history of science is littered with signals mistaken, dismissed, or misunderstood. Take the first pulsars, discovered by Jocelyn Bell Bernal in 1967, regular, repeating signals. For a brief moment, astronomers believed they'd found little green men, a code from the stars. It turned out to be the spinning hearts of dead stars. Pulsars, not aliens, but nature, tricking us with cosmic metronomes. How many times have we listened and not known what to hear? Dr. Emilio Saavedra, a signal processing expert at MIT, has spent his career re-examining old SETI data, looking for patterns in the noise. The truth is, he says, we don't know what an alien signal would sound like. We assume it will look like us, a radio ping, a steady frequency. But what if their language is so different, we mistake it for background static? He leans in, voice low. The universe may already be singing. We just haven't learned the tune. Consider light. For decades, SETI focused on radio. But what about lasers? What about optical beacons? New telescopes scan the heavens for impossibly bright flashes, pulses of light lasting billionths of a second. Some searches analyze the twinkle of distant stars, hoping to spot a pattern hidden in the flicker of digital Morse code, sent not in sound, but in photons. Then there are neutrinos, ghost particles that slip through planets like wind through a net. Could a sufficiently advanced civilization use neutrinos to communicate, knowing their messages would pass through anything? We have only just begun to build detectors sensitive enough to even glimpse these particles, let alone decode a message, or quantum entanglement, a phenomenon Einstein called spooky action at a distance. Could civilizations communicate instantly across vast gulfs of space, using quantum signals we haven't learned to read? Right now, these ideas belong to theory. But what will the science of 1,000 years from now reveal? For every channel we open, there are a million we haven't even imagined. Sometimes, the signals we miss are hidden by our own limitations. Our atmosphere blocks certain frequencies. Our detectors are tuned to human priorities, our years, our seconds, our bandwidth. And in a universe so old, so vast, a civilization could transmit a message for only a moment once every 1,000 years, once every million. If we blink, we might never see it. And then there is the question of time. If the galaxy is 100,000 light-years across, a message sent from one side could take millennia to arrive. What if signals from ancient civilizations have already washed over Earth before we even built radios? The sky is full of echoes, but how many have already faded? Dr. Saavedra recalls a story. In the early 2000s, a signal appeared in SETI's data pulsing, structured pattern. For days, the lab was electric with possibility, but it turned out to be a glitch from a malfunctioning microwave oven in the staff kitchen. Laughter, relief, disappointment. But sometimes, he says, I wonder what's hiding in the noise we laugh at. Maybe we dismiss the miraculous every day, simply because it doesn't fit our expectations. There's a danger in this expecting contact to look like us, to sound familiar. But what if it never will? What if the universe's silence is just a misunderstanding, a babel of physics and technology? This uncertainty isn't failure, it's a challenge. It's a call to listen deeper, to imagine more boldly, to search not just for what we know, but for what we've never considered. And so, the search continues. New algorithms sift the data, machine learning untangles the static. Researchers collaborate globally, re-examining archives, testing old assumptions with new tools. Maybe, just maybe, the first real signal isn't in the future, but already behind us, overlooked, waiting for the right eyes to see. But what if the signals we have found, pulsars, strange dimming stars, unexplained bursts, were more than mistakes? What if we're too quick to dismiss the extraordinary, simply because it isn't what we expected? To answer that, we must confront our own skepticism and the history of astronomy's greatest heartbreaks. There is a unique ache that only astronomers know, the ache of hope, sharpened and then shattered by the universe's indifference. Every generation of stargazers has faced its own mirages, signals that appeared for a shining moment to be proof that we are not alone, only to dissolve into the ordinary. These are the false positives, the heartbreaks of cosmic science. For decades, the search for extraterrestrial intelligence has been littered with these seductive near misses. The most famous, after the wow signal, are the pulses and patterns that seemed too regular, too purposeful, to be anything but engineered. But time and science are relentless in their scrutiny. In 1967, a graduate student named Jocelyn Bell Burnell picked up a steady, repeating signal on her radio telescope in Cambridge. At first, she and her advisor jokingly labeled it LGM1, little green men. The signal pulsed with perfect regularity, unlike anything known in the sky. Newspapers speculated about aliens. It turned out to be the first known pulsar-spinning neutron star, flashing like a cosmic lighthouse. Not a message, but a marvel of physics. These kinds of discoveries are a double-edged sword. They reveal new wonders of nature, yet each time they draw a curtain over the possibility of contact. Each false positive stings with disappointment, yet it propels science forward. Perhaps the most dramatic example in recent years was the case of Tabby's star, an unremarkable star in the constellation Cygnus that dimmed and flickered in ways no astronomer had ever seen. The leading hypothesis, popularized by Dr. Tobetha Boyargin and her team, was that vast alien structures, a so-called Dyson sphere, might be orbiting the star, harvesting its energy. The media exploded. The public's imagination soared. Even veteran scientists allowed themselves a glimmer of wonder. What if this is it? What if this is proof? But the extraordinary requires extraordinary evidence. Teams around the world race to find alternative explanations. Dust, comets, debris fields. Every possible natural cause was considered. In the end, the alien megastructure theory faded under the weight of data. It was, most likely, a strange configuration of cosmic dust. Tape Yagin, interviewed after the whirlwind, confessed to a complicated grief. For a brief moment, we all believed just a little. But science demands that we question and doubt and search for simpler answers. That's the beauty and the heartbreak. Yet the question lingers. Are we too quick to dismiss? Science is, by necessity, skeptical. The burden of proof is high, but humans are meaning makers. We hunger for connection, for discovery, for a sign. When we see patterns in the stars, our hearts leap ahead of our data. Some of the greatest scientific discoveries began as anomalous signals that didn't fit, dismissed until someone looked again with fresh eyes. How many possible signals have we ignored because they arrived in an unfamiliar language, or on an unexpected wavelength, or because we, desperate to avoid ridicule, decided not to look closer? Dr. Boyargin reflects on this risk. There is a cultural pressure in science to avoid the giggle factor, the embarrassment of chasing ghosts. But what if, in trying to avoid false hope, we close our minds to the real thing? There are entire catalogues of one-off anomalies, bursts of radio waves, fast radio bursts that flash across the sky and vanish. Most have natural explanations, but some remain unresolved, persistent mysteries. The universe is a master of camouflage. For every real discovery, there are 100 false alarms. Microwave ovens mistaken for cosmic beacons. Satellites misidentified as messages. Atmospheric events blamed on alien intent. Each disappointment leaves a scar, a lesson. Don't jump to conclusions. But don't stop imagining, either. This is the tightrope astronomers walk. Too much skepticism, and you risk overlooking the extraordinary. Too much faith, and you see patterns in the noise, and the stakes feel higher every year. With so many signals, so much data, and so many eyes on the sky, could it be that the real message is already here, buried under the weight of caution? Astronomer Seth Shostak from SETI likes to remind his team, we're not looking for proof, we're alone. We're looking for the one signal that breaks the rules. But how do we recognize it when we see it? How do we know when to trust our Wonder, viewers, what would you do, standing in the control room, when the data lights up and the algorithm hesitates? Would you announce a discovery? Would you wait? Or would you risk ridicule to chase a miracle? This is the human side of the cosmic search. Scientists who balance logic and longing, who dare to hope in the face of endless disappointment. Each false positive, a bruise. Each new anomaly, a flicker of hope reborn. But as the rejections pile up, and each new candidate fades, a subtle danger emerges. The risk of cosmic loneliness taking root not just in data, but in the heart. Yet, what if this very loneliness holds a lesson? What if our hunger for company is itself the signal, the thing that makes us ready, one day, to finally hear another voice? To understand that we must confront the impact of cosmic silence on the human mind and spirit. In the silence between stars, the human mind fills the void with longing, fear, and awe. No data point can measure it. No telescope can capture its shape. And yet, the loneliness we feel when we contemplate the cosmic void might be the most profound. Discovery of all. Psychologist Dr. Maya Cardenas sits in her office at the University of Buenos Aires, surrounded by images of nebulae and planetary systems. She studies not exoplanets, but emotions, the loneliness metric of our civilization. Her research began when she noticed how often space scientists, astronauts, and even the general public described a sense of vertigo when thinking about the Fermi paradox. It's a kind of existential isolation, she explains, like being the last person awake on a sleeping planet. She sees the effect in the eyes of astronauts who return from orbit, in children who stare up at the Milky Way for the first time, in philosophers writing late into the night about cosmic silence. But what is this loneliness, really? Is it the fear that we are physically alone, or the deeper terror that our story, with all its beauty and tragedy, will never be witnessed by another intelligence? Maya's research team conducted a global survey. How would you feel if humanity were truly alone in the universe? The responses ranged from pride, we must be special, chosen, the first, to despair. All of this, and for what? To vanish without being known. Some were pragmatic. At least there's no threat. Others were poetic. We are the universe made conscious, learning to admire itself in the dark. One of Maha's favorite responses came from in Morocco. If there's nobody else, then we should be the nicest planet ever. It's a reminder. Loneliness can hurt, but it can also inspire kindness. Astronauts like Chris Hadfield described the overview effect, the profound cognitive shift when seeing Earth from space. From orbit, all our wars, our noise, our divisions vanish. There's only one blue planet in a sea of black. It feels impossible that we're the only ones out here. But if we are, we'd better take care of each other. Maya uses brain scans to study what happens when subjects are exposed to reminders of cosmic isolation, vast images of galaxies, the silent data from SETI, the numbers behind the Drake equation, the amygdala, the center for fear, lights up. But so does the prefrontal cortex, the home of planning, empathy, and meaning-making. Loneliness, it turns out, is not just fear, she says. It's also hope. It's the drive to connect, to search, to make art and music and send golden records into the void. Philosopher Susan Schneider argues that this loneliness is evolutionary. Early humans survived by forming tribes, by connecting, by fearing isolation. Now, as a global species, our tribe is the planet, and the silence of the cosmos awakens that ancient fear. But in that fear is possibility. what would you do, standing beneath the sky, unbroken by alien voices? Would you despair, or would you create? Would you guard the light of consciousness as something precious, or would you see it as a burden too heavy to bear? Maya tells the story of cosmonaut Valentin Lebedev, who spent 211 days aboard the Soyuz 7 space station, staring at Earth through a tiny porthole. He wrote in his diary, "At night, I feel the emptiness pressing in, but it makes me realize how rare, how miraculous our little world is." This is the heart of the loneliness metric, the knowledge that in all this emptiness, we are the rarest thing of all, not because of what we've achieved, but because we have the capacity to care that we might be alone. And yet, loneliness is not only a human burden. Some researchers believe it is the true test of any intelligent civilization. How do you respond to the silence? With aggression, fear, or a deeper curiosity? Do you destroy yourself, unable to bear the weight? Or do you rise to become the narrator of your own cosmic story? Mahar's research suggests that civilizations that thrive may be the ones who embrace the void, who turn loneliness into a call for meaning, cooperation, and legacy. For you, watching this now, the cosmic silence is more than a scientific riddle. It's a mirror held up to your own life. When you face silence, what do you build? What do you reach for? Who do you choose to become? Comment below. Would knowing we're alone change how you live? Or would it inspire you to reach further? Love deeper, dream wilder. But what if this loneliness is not a curse, but an invitation? What if the universe is silent because it is still so young, and we are not the only ones, but the first to awaken? What if our burden is not loneliness, but leadership? To find out, we must look at the possibility that humanity isn't the only one, but the firstborn in a cosmic dawn. What if the silence that stretches across the cosmos is not a tombstone, but a birth cry? What if, instead of being left behind, we are the first to arrive? This is the provocative heart of the firstborn hypothesis, the possibility that the universe is young in ways that matter, and that we are not just early, but the very first to awaken. Dr. Anna Petrakis, a cosmologist at the Max Planck Institute, likes to frame it this way: in a universe 13.8 billion years old, the conditions for life as we know it have only recently become favorable. Most of the galaxy's planets are still cooling. Most of its stars are still in the prime of their lives. It's a radical shift of perspective. We're used to thinking of ourselves as latecomers to the party, scrambling for leftovers in a crowded universe. But maybe the opposite is true. Maybe the cosmic table is set, and we are the first guests. The science behind this idea is rooted in the way planets and stars are born. Heavy elements, the metals and minerals necessary for complex chemistry, are forged in the hearts of dying stars. Then scattered by supernova, the early universe was mostly hydrogen and helium, too simple for life as we know it. Only in the last few billion years have enough generations of stars lived and died to enrich galaxies with the ingredients for rocky worlds: water and DNA. Dr. Petrakis points to a recent study suggesting that the habitability curve of the universe is still rising. In other words, the majority of Earth-like planets haven't even formed yet. The cosmos may be on the verge of a great blossoming, and we're the first flower to open. It's a humbling, almost frightening thought. If we are first, then there are no elders to guide us, no ancient civilizations to warn us of dangers. Ahead, we are the test case, the blueprint, the possible ancestor of all future intelligence. Petrakis once led a seminar where she asked her students to imagine Earth as the EV planet, the first world where life became self-aware, the first to look up and ask, are we alone? The implications ripple outward. If we are first, then every choice we make matters on a cosmic scale. Every invention, every war, every act of kindness, all could echo down eons, shaping the destiny of worlds not yet born. But being first is not only a privilege, it is an enormous responsibility. Imagine, for a moment, that in 1 billion years, other civilizations will emerge. They will study the ruins of our cities, the signals we left behind, the art and mathematics we encoded in Voyager's golden record. We will be, for them, the ancient ones, the mythic forerunners. What legacy will we leave? Petrarchus admits, if we're the firstborn, our burden is to become wise ancestors, not just clever animals. She compares humanity to a young, powerful species standing at the edge of a vast forest, holding a torch no one has carried before. There are dangers in this role. With no one to warn us, we must learn every lesson ourselves about stewardship, technology, compassion, and hubris. The temptation to see ourselves as the center, rather than the start, of cosmic history is great. Pride can blind as easily as fear. But there are gifts. To be first is to be the storyteller, the message in the bottle, the ones who shape the myths for all who follow. What would you send if you knew your signal would become the beacon for all future civilizations? What story would you tell? What mistakes would you warn against? Viewers, comment below. If you could speak to the cosmos as the first, what would your message be? For Dr. Petrarchus, this perspective brings both hope and humility. Maybe we're alone right now, maybe we're not. But if we are first, then the future of the universe is not empty, it's waiting for us to write the first chapter. She sometimes walks the grounds of the observatory at night, looking up at stars that may not yet have planets, let alone life. She says, every silence I hear is a question, and every question is a chance for us to answer. But if we are first, it means something else, too. The universe is not empty. It is pregnant with possibility, and in that possibility lurks another question, deeper and darker. What if the silence is not about youth or age, not about waiting for life to begin, but about fear? What if the darkness hides more than promise? What if every civilization that learns to speak also learns to hide? For that, we must enter the shadows of the dark forest. Imagine the universe not as a bustling metropolis, nor as a lonely wilderness, but as a vast ancient forest at midnight. Every civilization, every world that achieves awareness, becomes a single, trembling life form in the undergrowth. The trees loom, shadows stretch, and the silence is not empty but filled with the fear of being found. This is the chilling premise of the dark forest theory, a concept born from the mind of Chinese science fiction author Liu Cixin and increasingly debated by physicists and philosophers. Its logic is as simple as it is brutal. In a universe where survival is the highest priority, the safest course is to stay silent, to hide, because every other voice in the dark may be a potential threat. Dr. Jia Chen, a theoretical physicist at Tsinghua University, frames it in stark terms. Every civilization is an armed hunter in the dark forest. If you reveal yourself, you risk attracting attention from something you cannot see, cannot understand, and cannot predict. The theory turns the Fermi paradox on its head. The silence is not a mystery, but a survival strategy. In this scenario, trust is impossible. Communication is risk. To send a signal to announce your existences to gamble with the fate of your entire species. No matter how peaceful your intentions, you cannot know the motives of unknown intelligences, like away. The first to speak might be the first to fall. It's a theory rooted not just in fiction, but in evolutionary psychology and the grim lessons of history. On Earth, when isolated tribes or species meet, the encounter is rarely peaceful. Power, imbalances breed conquest, fear breeds violence. In the dark forest of the cosmos, the stakes are infinitely higher. Dr. Chen recalls a simulation her team conducted. They seeded a virtual galaxy with thousands of civilizations, each governed by different rules, some curious, some cautious, some aggressive. Over millions of simulated years, the civilizations that stayed silent survived the longest. The ones that announced themselves were quickly wiped out, sometimes by more advanced neighbors, sometimes by coalitions who saw their emergence as a threat. We used to imagine first contact as a hopeful encounter, Chen says. But what if it's a game with only one rule? Don't be seen. The implications are unnerving. Perhaps every planet that ever learned to broadcast has gone silent, not by choice, but by necessity. Perhaps the dead worlds we observe, where signs of past life flicker and fade, are the echoes of civilizations that dared to speak. It reframes the question of the great filter, too. What if the filter isn't just self-destruction, but mutual destruction? What if it's not just that civilizations destroy themselves, but that, in fear, they destroy each other? There's a grim poetry to this universe. 100 billion civilizations, each hiding, listening, hoping to survive one more cosmic night. The darkness becomes both shield and prison. Yet, humanity is already broadcasting. Our television signals, our radar, our leaking atmospheric fingerprints, all escaping into space, announcing our existence. If the dark forest is real, our innocence is gone. The genie is out of the bottle. But Dr. Chen argues that hope is not lost. Even in a dark forest, alliances are possible. Shared silence can be a form of communication. The very absence of aggression over time can build a kind of trust. Still, the tension is suffocating. Should we keep searching? Should we send more signals, actively reach out with active SETI? Or should we go dark, cloak ourselves, hide our technological signature? The debate rages among scientists and strategists alike. What would you do knowing the stakes? Would you risk everything to make contact or counsel patience, secrecy, silence? Viewers, if you were in charge of Earth's signal, would you press send or mute? It is possible that the silence we encounter is not accidental. It is not a mistake or a gap in technology, but a choice, a galaxy-wide Cold War of invisibility. And yet, even in the dark forest, not everything is what it seems. History shows that fear can be overcome, alliances can form, new rules can emerge, not from trust, but from mutual recognition of vulnerability. After all, even a forest at midnight is alive with life we cannot see, hear, or imagine. Shadows flicker, eyes glow, and survival takes many forms. Perhaps the quiet is not absolute. Perhaps it is simply deeper, stranger, more encrypted than we expect. But what if the clues are not out in the endless void, but much closer to home? What if, while searching for distant threats, we have missed signs in our own cosmic backyard, anomalies, artifacts, whispers hidden in plain sight? To answer that, we must look not to distant stars, but to the mysteries orbiting our very own sun. Sometimes The greatest mysteries are not light years away, but hidden within the shadowy reaches of our own solar system. As we stare into the deep cosmos, scanning for signals and civilizations, we may have overlooked the possibility that the evidence is already here, silent, patient, and disturbingly close. NASA astrophysicist Dr. Kevin Trask walks the halls of the Jet Propulsion Laboratory, surrounded by models of spacecraft and 3D printed asteroids. But his eyes are always drawn to the data feeds. The endless stream of telemetry from probes circling Jupiter, Saturn, and the lonely expanse beyond Pluto. People always imagine aliens as distant, Trask says. But if you were a watcher, you'd send probes, not starships. You'd observe quietly, with technology hidden from sight. This is the premise behind the alien artifact hypothesis, that our solar system might already be home to non-human technology. Not flashing saucers or buzzing drones, but ancient, silent machines, observers, beacons, or even monuments waiting, perhaps, to be found. Consider Oumuamua, the first known interstellar object to pass through our solar system in 2017. Moved too fast, followed an odd trajectory, and showed none of the coma or outgassing expected from a comet. Harvard's Dr. Avi Loeb caused a storm when he suggested it might be an alien probe. Tumbling through the dark on a silent reconnaissance mission, mainstream science scoffed at the idea, but a thread of doubt lingered. What if our first visitor from another star was not a rock, but a relic, a message in motion? Dr. Trask recalls another mystery, the Black Knight satellite, an object in polar orbit, first detected by radio operators in the 1960s. Legends have grown around it. Some claim it's a fragment of a lost probe, others an echo of Cold War paranoia. Officially, it's dismissed as debris, but still, the myth endures. Then there are the Martian anomalies, strange geometric features in photos from Mars orbiters, the infamous face on Mars in Cydonia, and angular patterns on asteroids like Eros and Phobos. With each mission, high-resolution images have debunked most claims. Yet, for every answer, a new question seems to surface. Why do we long so deeply to find evidence just out of reach? Perhaps, Trask suggests, it's not all wishful thinking. He points to the Moon, Earth's nearest neighbor, and a time capsule of solar history. Lunar reconnaissance orbiter images have revealed thousands of craters, caves, and even possible entrances to subsurface tunnels. Some researchers quietly propose scanning these shadows for artificial signatures, metal alloys, radio echoes, or geometry that cannot be explained by geology alone. And then, there's a far more chilling possibility that the very probes we've sent into space could themselves be discovered and studied by something or someone else. Imagine Voyager, billions of kilometers from home, intercepted by silent watchers. Who, then, becomes the subject of the experiment? Dr. Trask describes the challenges in searching for alien artifacts. Space is vast, even our own backyard between Earth, the asteroid belt, the Kuiper belt, a graveyard of rocks and dust. If an artifact was designed to avoid detection, it could hide for millennia. Sometimes, the signs are subtler, strange orbital patterns, unexplained accelerations, or debris fields that don't fit the models. Most have prosaic explanations: physics, chance, computer error. But the scientific method demands skepticism and curiosity. After all, every paradigm shift in history began as an anomaly. Trask recalls a heated debate at a SETI conference. Should we devote resources to searching for artifacts, technosignatures, as well as listening for signals? Some fear it edges too close to conspiracy, risking ridicule and lost funding. Others argue that ignoring possible evidence in our own backyard is the greatest failure of imagination. And what about the possibility that any artifact would be so advanced, so camouflaged, we'd never recognize it? Arthur C. Clarke's famous dictum comes to mind: any sufficiently advanced technology is indistinguishable from magic. So, we scan the skies and the rocks and the dust. We test for unusual isotopes, for straight lines in places there should be none, for objects moving against the natural tide. Viewers, if you found an artifact hidden in the asteroid belt, buried on the moon, tumbling in the cold between worlds, what would you do? Would you announce it, keep it secret, or worry about what Tohu it might awaken? Perhaps we are not just watchers, but the watched. The deeper we look into our own solar system, the more we realize that the line between natural and artificial, known and unknown, is razor thin. Maybe the real proof of life out there will not come from a distant signal, but from a relic already orbiting our sun. But what if, in the search for artifacts, we stumble into something even more unsettling? What if the silence we detect is not just natural, but actively enforced? To understand, we must confront the possibility that secrets have been hidden, erased, or covered up not by aliens, but by our own hands. For every mystery revealed by science, there are others that slip into the shadow stories of vanished signals, lost tapes, or quiet interventions that leave us wondering what or who is keeping the silence. Some researchers whisper about a force more elusive than alien artifacts or distant beacons. They call them the silencers, not visitors from the stars, but those among us who erase, distort, or bury the evidence. Sometimes for fear, sometimes for power, and sometimes, perhaps, because the truth is simply too dangerous. The history of the search for extraterrestrial intelligence is scattered with rumors of cover-ups and missing data. In the 1960s, as the Cold War deepened, SETI's early pioneers, Frank Drake, Jill Tarter, Carl Sagan, faced not just skepticism from the public, but scrutiny from intelligence agencies. National security demanded secrecy. Radio signals that might, even faintly, resemble coded transmissions were often swept up, analyzed, and quietly set aside. We were always one step from being shut down, Dr. Tarter recalled. Anything unexplained was treated as a threat. But there are more enigmatic stories, too. In 1986, an engineer at a radio observatory in the Soviet Union picked up a sequence of structured pulses from the direction of Cygnus. The signal was never repeated on when he tried to retrieve the recordings later. The tapes were missing. He found a fresh lock on the lab's door. His colleagues dismissed it as a technical glitch, but he never believed it. There are whispers of NASA tapes erased, SETI signals quietly reclassified, unexplained anomalies written off as data corruption. Sometimes the motivation is mundane: budgets, politics, embarrassment. No one wants to be the scientist who cried, alien. But sometimes the motivation runs deeper. If we found proof, asks Dr. Mariana Liu, a sociologist who studies the culture of secrecy in science, who gets to decide what happens next, would we share it? Or would governments hide it, fearing social upheaval or loss of control? Liu describes the concept of cosmic censorship, the idea that societies, even unintentionally, conspire to suppress evidence that threatens their worldviews. There's a kind of self-silencing in science. We avoid the giggle factor. We overcorrect for skepticism. Sometimes, in trying to protect ourselves from false hope, we close our eyes to real possibilities, and the stakes are not just scientific. Imagine a signal is detected, real and undeniable. Who hears it first? The public, the military, the president. What about those who fear the cultural, religious, or psychological consequences? Who stands guard over the silence, and at what cost? There are modern stories too. In 2015, an encrypted memo leaked from a European deep space listening post. It described a sequence of narrowband bursts, repeating every 19 hours from a fixed point in the sky. Within days, the project's public updates went dark, citing technical maintenance. The signal was never discussed again. Was it a mistake? A technical artifact? Or a real anomaly quietly erased from the official record? The silencers may not wear black suits or carry ray guns. Often they wear lab coats, or sit on government panels, or simply make decisions in the blur of midnight. Doubt. Their motives are not always sinister sometimes. It's just easier to protect the public from wonder than from panic. Dr. Liu invites viewers to reflect. If you were the one who found proof of alien life, real, undeniable, irreversible, would you share it with the world, knowing the consequences might be unpredictable? Or would you bury it, hoping someone wiser could handle it? There's another side to silencing too. Some suggest the very absence of evidence could be the evidency coordinated. Deliberate non-disclosure, not by humans, but by extraterrestrial civilizations themselves. This is the theory of the cosmic quarantine that any species advanced enough to monitor us would also be advanced enough to hide itself, cloaking its signals, erasing its footprints, ensuring we only find what we're ready to understand in the end. The silence of the universe is not just a puzzle of technology or distance, but of psychology and trust. Who decides what truths are safe to share? Who guards the gates of wonder? And who, in the deepest moments of fear or awe, chooses silence over revelation? Perhaps the greatest barrier is not out there, but in herein the architecture of human doubt and hope. But what if the next message we receive is not hidden at all? What if, somewhere, our signals are already being heard and interpreted by eyes as curious as our own? What would they learn about us not from our discoveries, but from our daily noise, our broadcasts, our songs, and chaos leaking into the void? 2. See ourselves as others might. We must turn the telescope around and look at Earth not as home, but as a distant, mysterious signal in the dark. Imagine floating light years away, a stranger to Earth, armed with instruments built to eavesdrop on the cosmos. What would you find if you detected our little planet swirling around an ordinary yellow star? What would the sum of our signals, our noise, our chemical fingerprints, reveal to an intelligence searching for company in the dark? This is the mirror we seldom hold up to ourselves, reflection not from our own eyes, but as seen by another. Dr. Emilio Park, an exoplanet spectroscopist at Caltech, spends his nights decoding starlight, separating the faintest signals from the background noise. We're already visible, he says, long before we ever meant to be. Every radio and TV broadcast since the 20th century, every military radar sweep, every satellite pinches has rippled outward, creating an expanding bubble of electromagnetic noise over 100 light-years across. If someone is listening, Emilio says, they already know we're here. They might even know what soap operas we loved in the 1960s. But our presence is more than just radio waves. Advanced civilizations might look for biosignatures, gases in our atmosphere that only life can produce. For billions of years, Earth's oxygen has glimmered like a beacon, hinting that something remarkable is happening here. Recently, methane, chlorofluorocarbons, and even faint traces of pollutants have been detected by our own telescopes, evidence, perhaps of technology at work to another species. We might appear as a world in transition, a blue planet alive with chemistry, civilization, and change. Our nights sparkle with city lights, one side of our world glowing softly as the other sleeps. Our moon, unique in its size, betrays a planet that's stable, shielded, and perhaps even watched over by luck. But what else might an alien civilization see? Dr. Park and his team run simulations. They blur our signals, degrade our data, and watch as continents fade, oceans blend, and only the most persistent signals remain. Human-made artifact satellites, space junk, even the golden records aboard the Voyager probes become almost invisible, mere pinpricks against the vastness, and yet something else endures. Our transmissions, TV, music, news, drama might be one of the first impressions another intelligence would have of us. Imagine a distant world's astronomers catching the opening chords of Beethoven, or the chaos of a live sports broadcast, or a fragment of breaking news, all years or centuries out of date. For a moment, pause and reflect. If you were out there, listening, what story would you think Earth is trying to tell? But it's not just our broadcasts. The cosmic mirror reflects our conflicts, too. Military radars, nuclear detonations, and political signals leak outward with equal energy. Our story, as told by our signals, is not just one of art and curiosity, but of fear, ambition, and unrest. Dr. Park muses, our first impression may not be our best. He wonders, sometimes with a smile, sometimes with a frown, whether we'd be seen as a civilization ready for contact, or a world best observed from afar. There's another layer, more philosophical and haunting. For all our attempts to craft messages for alien listeners, the Voyager Golden Record, the Arecibo message, the plaques on Pioneer, these are deliberate, hopeful, even poetic. But the real story of Earth is told in our unintentional noise. The mundane, the passionate, the accidental, our laughter and anger, love songs and cries for help, all mixed together and beamed into the endless dark. And yet, all these signals fade with distance. Cosmic dust, interstellar plasma, the slow degradation of time. If we do not persist, our civilization ends. Our bubble of noise will expand, weaken, and eventually vanish, becoming just another whisper in the galactic static. So what would you want a distant watcher to know about us? What would you send if you could craft Earth's introduction? Viewers, in the comments, share the message you'd want the universe to hear from humanity. What part of our story deserves to outlive us? Dr. Park's students debate whether aliens would understand our mathematics, our languages, or our art. Some believe that only the logic of physics, the pulse of prime numbers can bridge the gap. Others hope that the emotion in a song or the beauty of a painting could speak across light years. But in the end, the mirror shows both what we intend to reveal and what we cannot hide. Our strengths and our scars, our triumphs and our tragedies, all reflected for any who care to look. Perhaps, even now, a distant civilization is turning its instruments toward our sun, puzzled and intrigued by the story emerging from a tiny blue world. But what if, in all our searching and all our sending, we're missing a crucial point? What if silence itself is the most important message of all? To find out, We must listen for meaning in the quiet and ask if in the absence of reply there's a deeper code waiting to be heard. For centuries, silence was only the space between signata, void, and absence, a disappointment. But what if we've misunderstood it? What if the silence itself is the message, encoded in patterns we've yet to decipher, in meanings that escape our senses and assumptions? This is the strange and haunting idea at the frontier of modern SETI. Mathematician Dr. Anil Rowe at the Indian Institute of Science spends his nights not searching for beacons, but looking for order in the noise, the possibility that the universe's silence is a code, and that the absence of obvious contact hides a deeper communication. Anil runs statistical analyses on the radio static that fills our detectors. Pure randomness, he explains, almost never exists in nature. Even in what we call white noise, there are subtle fingerprints, patterns, repetitions, deviations from pure chaos. If an advanced intelligence wanted to send a message that only a prepared mind could recognize, they might hide it in the one place we always overlook, the background itself. Imagine a puzzle so well hidden that only a civilization willing to listen for millennia would ever find it. Perhaps the silence we hear isn't a blank wall, but a carefully modulated landscape, like Morse code slowed beyond recognition, or information written in the quantum foam of space itself. This concept isn't entirely science fiction. In the 20th century, cryptographers learned to hide messages in plain sight, using techniques like steganography concealing data within ordinary images or sounds. A pattern in the static, a deviation in cosmic microwave background, signals that look like noise, unless you know exactly how to look. Rao's team works on algorithms that search for non-randomness in cosmic noise. They analyze data from radio telescopes, searching for mathematical relationships, prime numbers. The Fibonacci sequence, Python would never occur by chance. So far, they've found nothing conclusive. But the possibility haunts the field. Could it be that the universe is teeming with messages, so deeply woven into the fabric of physics that only a species ready to ask the right question could unlock them? This is not just a technical puzzle, it's a philosophical one. What counts as a message? Is contact only valid if it shouts across the stars, or can it whisper through the very laws of reality? Rowe believes it's possible that communication might transcend language, form, and even intent. A sufficiently advanced civilization might leave its mark not as a beacon, he says, but as a patterner, rule of symmetry, an algorithm, a fundamental constant subtly altered to say, "You are not alone." SETI's history is full of searches for deliberate signals, radio pulses, laser flashes, artifacts. But this new approach challenges us to widen our perception, to accept that absence can be meaningful, that a blank space can be the canvas, not the void. But how would we ever know? It is a question that pushes the boundary between science and faith. Some scientists worry about seeing patterns where there are none, falling into the trap of pareidolia, like seeing faces in clouds or shapes on Mars. Yet all true discovery begins with a question that others dismiss. Dr. Rowe remembers a childhood story from India, a king who sent a blank sheet of paper to his rival, intending it as an insult. But the rival, wise and curious, saw it as an invitation. In every silence, Rowe says, there can be meaning if we choose to look for it. For viewers, this is a chance to reflect. What would you make of a universe that never speaks directly, but offers hints, riddles, and the challenge of persistent curiosity? Would you keep listening, even if the answer is forever just out of reach. And there's another, more speculative twist. What if silence is not only a message, but a test, a cosmic filter for patience, humility, and ingenuity? Only those willing to endure the absence, those who don't give up or descend into despair, ready for what comes next. Perhaps, in this view, our greatest achievement is not discovering a signal, but continuing the search, refining our questions, and finding meaning even in uncertainty. Rose sometimes stands alone atop the observatory dome, looking up at the star-powdered sky. He listens to the hiss of the detectors, the cold music of the void, and wonders, are we missing something, hiding in plain sight? Maybe, one day, the silence will crack. Or maybe it will not. But in every moment, we choose to listen, to imagine, to question, to seek. We become part of the signal ourselves. The ultimate message may not come from another world, but from what we become in the search, patient, creative, resilient, united by wonder. But if the universe never answers, and if we are truly alone in this immense and echoing dark, then the final question is not scientific, but moral. If the universe has given us nothing but silence, then perhaps it is not an answer we await, but an invitation to shape the meaning of existence itself. In a cosmos without echoes, every word, every act, every story we create becomes the very first note in a symphony that may last for billions of years. This is the burden and the blessing of being the first voice. Dr. Lena Morris stands again at the Allen Telescope Array where our journey began. She stares at the web of antennas stretching beneath the cold dawn sky, feeling the weight of the quiet pressing in. For decades, she has listened, searching for another intelligence, another consciousness, another us. The silence, she realizes now, is not empty. It is raw potential, as fertile and frightening as the first spark in the dark. The responsibility of being first is unlike any other. We have no elders, no cosmic mentors to warn us or console us, no ancient stories to lean on. Every mistake we make, every step we take, may be the first of its kind in the history of life. What will we teach the universe, should anyone follow in our wake? Astronauts returning from space often speak of a profound shift, a sense of unity, fragility, and stewardship. They look back at the blue world and see a single living story, a tapestry woven from a million small hopes and failures. In the void, they understand, we are one species, one fragile experiment. If our voice is the only one, then its tone, its message, its music matters more than we can imagine. Dr. Maya Cardenas, whose research on the loneliness metric helped us glimpse the psychological cost of cosmic solitude, sees another side. If you are the first, she says, you are also the teacher. Every kindness, every act of creation, every dream is a seed for a future you cannot see. She reminds her students that even in isolation, meaning multiplies because meaning is made by those who care. The burden of the first voice is not just survival, but legacy. The signals we send, art, music, mathematics, laughter, confessions, become the DNA of the cosmos. If others rise after us, these fragments may shape their myths, their philosophies, their sense of what is possible. And if no others ever come, then our stories are still written in the fabric of time, a testament to what matter, organized and alive, could become. There is fear here, too. With no guide, we face every darkness unprepared. Our technology races ahead of our wisdom. Our divisions threaten the only experiment in consciousness we know. Dr. Richard Hannah's warnings about the great filter ring louder than ever. Will we last? Will we leave only ruins? Or will we endure as caretakers, explorers, and artists? Lena Morris walks between the telescopes at night, remembering the moment she first heard the wow signal, the thrill, and the heartbreak. She wonders if, someday, another world will listen to the echoes of our broadcasts, piece together the joy and the noise, the wars and the discoveries, and see in us not monsters or miracles, but kindred, spirits alone for a time, but never truly lost. For those watching now, the cosmic silence asks not just for patience, but for courage. The courage to imagine new futures, to care for a planet that might be the only oasis in an endless sea. The courage to dream, to send out messages, to teach and learn and create even if no one ever replies. What would you choose to send into the dark? What story would you tell, knowing you might be the first and the last to do so? If the universe is waiting for its first note, what melody would you play? Comment below. If you could speak for all of humanity, what would you say to the stars? Dr. Anil Rowe, searching for hidden patterns in the noise, calls the burden of the first voice a sacred gift. To be alone is to be free to invent meaning, to create beauty, to become the ancestors of all who might follow. He urges us to see the silence not as a verdict, but as a blank page. The silence of the cosmos is not an accusation. It is a promise that every sunrise, every act of wonder, every song and sorrow can echo farther than we will ever know. That even a single voice can change the shape of forever. So perhaps the truest answer to the question, are we alone, is not fear or despair, but a vow to live, to learn, to send our story outward courageously, kindly, as the first voice in the cosmic dark, and as the antennas sweep the sky, as dreams leap from mind to mind, as each of us adds a note to the symphony, the universe grows less silent and more alive, because in the end, the only meaning the cosmos will ever know is the meaning we give it. The silence may be terrifying, but it also means the future is unwritten. If we are alone, then we are the first storytellers of the cosmos. Like, subscribe, and share your thoughts below, because in a universe this quiet, even your voice might echo forever. Are we really alone?